So we're using the information, the actual linear regression equation that we found yesterday to predict a few fare prices for different flights that they're stating. I don't really know why they're giving you this chart here that has everything listed out, because that's everything we figured out yesterday. But the main thing I wanted to point out is we're using the equation that we found yesterday to predict prices of flights depending on the miles. So that equation, just to give that to you all again, that we found yesterday was 0.0786x plus 177.215. Okay, so we're going to use this model to predict the prices of two different flights. One that is 392 miles and the other that is 1,719 miles. So to do that, we just plug in 392 for x for that side, and then we plug in 1,719 for x on this side, and it's going to give us a rough, like an estimation of how much those flights cost. So we're going to do y equals 0.0786 times 392 plus 177.215. And on this side, we have to do the same thing, but we have to plug in the different miles or the different flights information. So 177.215. So when we do that, because we didn't do this yesterday, we get 208.03 for the 392 mile flight. And then for the 1,719 mile flight, we get a predicted price of 312.33. Okay, so I'm gonna kind of just point out that both of these are predicted. Okay, they're not exact, because what we ended up using, or what ended up happening, is we used some data from a chart, and we came up with a line of best fit that roughly estimated or gave us an equation that fits the data the best or the closest. So the two answers that we get are like not exact. Those are actually how much the flights cost. It's a good prediction of how much you would be willing to, or be actually paying for those two flights. So both of those are predictions. Mainly any fare price that you get using the model that we came up with are predictions. So for the next two, it says to calculate the residual for a flight to Orlando. And then we're going to do the same thing. Calculate the residual for a flight to Las Vegas. Truman, what's the residual? Okay. So residual equals, yeah, so actual minus predicted. Okay. So, and then the same thing on the right. So the residual equals to the actual minus the predicted. So this is kind of what a residual is. It allows you to see, like, kind of basically how far off you were from your prediction to how much it actually costs to go to those flights, or to fly out to those two places. And if you want to find out the actual prices, we have to turn to the chart from yesterday, which I have here somewhere. Where did I put it? Okay, we have to turn to the charts from yesterday to actually find the actual price to fly to those places. So to fly to, what was one of them? Orlando, 238. So we'll write that down. Keep losing track. Okay, so to fly to Orlando is 238. So this would be 238 minus our predicted amount that we found out, which was 0.03. So the residual that we get, so we get R equals to 29.97. Okay, that's the residual amount. And then we do the same thing off just for a different flight to Las Vegas. And the actual price to go to Las Vegas is $252. So R equals 252 minus what we predicted it would cost, which is 312.33. So R equals to negative 60.33. Okay. So kind of start to understand what a residual represents, like what the concept of that means. We talked about it a little bit yesterday. It's covered in the notes from yesterday towards the bottom, I believe, or the second page, I'm sorry. Okay, so where it talks about, where was it at? Towards the bottom. Okay, so a residual is basically like your amounts that you're off by. It's an error term. So it's how far you were away from the actual value using the prediction that you used. So that's kind of what it represents. All right, so here. Okay, so yesterday we kind of recapped how to find the linear regression equation. Using that, we use it to predict different fare prices. Now we've figured out how to calculate a residual cost or residual amount, and then what's only different today is we're gonna talk about how to create a residual graph. Okay. Yesterday we made a scatter plot, and we found out a line of best fit that fit the data the best. Today we're going to do the same thing, but we're going to create a residual chart that kind of displays slightly different information to see how off you were from your predicted amounts for different predicted prices. Okay, so that's kind of the only difference we're going to do today. But a lot of this is going to be a repeat of what we covered yesterday. So we're going to go down to the next page, okay? Because we'll talk about how to sketch those. So this is the actual example we'll go through. So we are going to first, what you may have to do is go to your list in your 84s and clear out everything that's in it, and beta 0 off to the side. Okay, that's just a fancy word for, okay, this is your, kind of like your slope. Okay, and this is your y-intercept. Okay, it's how they kind of label something in stats. So when you say beta 1, it's kind of referencing the slope of your equation, and beta 0 is the y-intercept, like where it's initially starting off. It's just two different terms that they use in stats to express an equation in this form. Instead of mx plus b, they use beta 1x plus beta 0. Okay, it's just a different way of expressing it. So we want to we want to find out the equation to this data. So we're going to run a linear regression. So we're going to do stat, calc, and I kind of told you yesterday, you want to use option 4. Okay, hold on. Let's backtrack. Go to mode. Make sure the stat diagnostics is on. It's going to be off for everyone's. Okay, so make sure you turn it. Yeah. Hit mode, and then towards the bottom, make sure it's on. There's one calculator out there that doesn't show it. Okay, that's yours. Okay, just here, use this one. Okay. Yeah. Yeah. Because if it's not, it won't show us what we need. That one should be on already, Santana. Or actually, it won't, because I cleared it out too. Just make sure. Okay, it's on. Okay. So once it's on, just go back to stat, calc. We're going to run a linear regression, because this is linear data. Hit enter. L1, L2. What I want you to do here, where it says store the regression equation, type in. Let's see if I remember how to do this. Vars, yeah. So hit vars, y vars. I'll do it the other way. Okay. So go to, if yours looks like mine, like if your screen looks like mine. Okay. L1, L2 is good, but here where it says to store, we want to store the equation that we get under a variable. Okay. So that way you don't have to type out like 30 numbers. So if you don't want to do that, you're able to store the equation that you get under like a letter, basically. So that's what I'm going to do. So to do that, here you go to vars, scroll over to yvars, function, and we're going to store this under y1. Okay. The alternative to this is you write out every single number that you get in the equation, which is not going to be fun. Okay, that's the alternative. So you hit calculate. Okay, so if your screen,
Mr. Solis, you lost me. Well, it's like, so I'm
where?
on this, the store, yeah, I'm on that. Go to bars.
Okay, right, you're here, right?
Yeah. And then click bars.
Down here.
Yeah.
Okay, so vars, y vars, function, and just choose y1. Basically, you're telling the 84 whatever equation that you get, plug it into y1 because you're gonna have to do it anyways. So hit y1, calculate, and then you get this. Okay, so if y'all's if yours didn't have that, let me see if I can pause it there. So vars, y vars, function. Yeah. Okay, so if y'all's didn't have that, like if yours doesn't have this updated screen, the alternative is for y'all to do when it shows like linear regression, do L1, L2, Y1. So you have to type it in manually.
Do you want us to wrap Y1?
Yeah. Where's Y1? Well, you have to do that. You have to do vars, y vars. So it should look like, before you hit enter, you should have this typed out.
Yeah.
Oh, you have to hit vars. You have to go here. Vars, y vars, and then enter, and then hit that one. And it should place that in there. You got it? Hit enter. Like after you have those typed in, hit enter. So L1, L2, Y1, I'm sorry, and then hit enter. Hopefully it works. It should work. Linear regression. Stat, calc, test, linear regression. Yeah. Well, the point of doing that is now when you go to y equals, your equation's in there. You don't have to type. You don't want to write all those digits down and have to type those in. That's the point of doing all this. Okay. Unless you want to sit there and write your entire equation out off to the side and then come back and rewrite it into y1, then that's the alternative. So we go to calc. I'm gonna have to do it again just because. So. Well, that's why Anna, I told you have to L1, L2, Y1. Oh. So you should have this. Okay. Okay, so under beta 1, that's your slope. Okay. So type in, or you're gonna write 0.635 if you rounded. Okay. Stat calc test number 4. Beta 0, that's your y-intercept. It's 64.928. And then r equals 0.994. R squared equals 0.989. Okay, so let's write that. So 0.635 was your slope. Y-intercept was this. R was equal to 0.994, and then R squared was equal to 0.989, which is 98. Remember, R squared you always represent as a percent.